Hello everyone. Welcome to our video on finding the equation of a line in slope-intercept form. So there's three forms to a line. We have the slope-intercept form. This is usually best when we need to graph something. It's also usually the best form just to kind of have overall. The point slope form, so we have y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is a point on the line. This one's usually good for finding an equation to a line. So this one's good to start with finding the equation. And then the general form is often just given to us a lot of the times, and it's kind of only okay in some cases, so it's the least useful. However, let's go ahead and break down how we can use some of these equations to help us with these problems. So in this example, we're going to find an equation in slope-intercept form for each line. Now, we are going to start with the point slope form. So to find an equation of a line, so that's what's important about this, we need two things. We need the slope and we need the point, or we need a point. So our slope is m and our point is usually designated x1 comma y1. Okay, and so that's what we'll do on this problem. Well, this one, they gave us both things. They gave us the slope and they gave us the point. So let's go ahead and label that x1, y1. And then from here, we're actually going to start with the point slope form of a line. So we start with this. We can do it in other ways. However, I think this is often kind of the most straightforward method. And once we have this set up, well, we'll just plug all this stuff in. So we have y minus y1 is 10 equals m, which is negative 5/2, x minus x1, which is 4. Ooh, my pen kind of freaked out there. Minus 4. Okay, and then even this, it might be useful to keep it in parentheses. So everything I substituted in is in parentheses. And then after we sub all this in, our goal will be to solve for y. So put it in the slope-intercept form for y equals mx plus b. Okay, so the first thing that we do, well, we can distribute the negative 5/2. And then we kind of don't need those parentheses anymore. I think it's useful to use at the start, but once we're no longer needing them, well, you don't need to write them anymore. All right, well, the negative 5/2 distributes, so it's negative 5/2 x, and then negative 5/2 times a negative would be positive. 5/2 times 4, I'm just going to do that to the side, scratch work. 5/2 times 4, it would be 4 over 1. And remember, you could multiply straight across, or you could look to divide first if something divides. And so 4 divided by 2 is 2. So this is really just 5, and you could mark it like this as needed. So 5 times 2 over 1 times 1, and so that becomes 10. Okay, so let's just show that. So this 5/2 times the 4 became 10. And then I need to get the y completely by itself. So at this point, we could just add the 10 over. And then from here, we've got y equals negative 5/2 x plus 10. Oops, 10 plus 10 is 20. There we go. Okay, so sorry about that. 10 plus 10 is not 10. 10 plus 10 is 20. Okay, so that's it. So we've got our final answer. One thing you could do to check, well, it does have the same slope. So instantly we could check that. Does this point work? Well, you can use this point in this equation to verify. So if we plugged in 10 and plugged in 4 for x, does this hold up? Is this true? And yes, it is true. On the right, that does simplify. It would be 10 equals 10. Okay, so that looks like it works. Okay, so let's see some other cases. In the second case, in problem number 2 here, we're still finding the equation, but we have 2 points. So they didn't give us the slope. Well, we still need the slope. Okay, so let's get our slope. Okay, so let's get the slope. So need slope, and we don't have it. So let's get it. So our slope well, we've got an equation for that. We also, oops, I wrote y2 twice. So our equation is y2 minus y1 over x2 minus x1. So we do have that equation. However, it still might be nice. Let's put it over here where we do a very, very quick sketch. So -3, so 1, 2, 3 to the left, and then down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 6 and 2. 1, 2, 3, 4, 5, 6. And then up to 1, 2. Right there. Okay, so we can see that it is a positive slope. All right, and then now let's plug in these values. Let's mark them. So this is our x1, y1, x2, y2. And when we plug them in, okay, so y2 is 2 minus y1, which is -8, over x2, which is 6, minus x1, which is -3. And we would have 2 minus -8 is 2 plus 8, really. And then 6 minus -3 is really 6 plus 3. So it looks like it's 2 plus 8 is 10. 6 plus 3 is 9. Okay, so that's our slope. I'm just kind of clouding it because it's not our final answer. Okay, and then we need a point. Notice it is positive 2, which matches the steepness of it. Should be positive. And then we need a point. Well, we already have a point. And you could choose whichever one you prefer, actually. You could choose this one. You could choose that one. It doesn't matter. I'm just going to go ahead and choose that first one because it's already marked as x1 and y1. Okay, so now that we have the slope and the point, now we can go to our equation, our point-slope form, which is y minus y1 equals m times x minus x1. And so now we can plug in all of the information that we have. So we have y minus y1, which is -8. Again, be careful, use the parentheses because we're going to see that it's going to become plus 8. Our slope is 10 over 9. And then x minus x1, x1 is -3. So again, use those parentheses. Okay, so because I have double negatives, let's go ahead and do this step where we just change the double negative. So y plus 8 equals 10/9 x plus 3, like that. And then the 10/9, I no longer put parentheses around because in this next step, I'm going to distribute anyway. So 10/9 multiplies both of those. So now our goal is to solve for y. And when we distribute, we have y plus 8 equals, well, 10/9 times x is 10/9 x. 10/9 times 3, I'm going to do that scratch work to the side. And then, well, again, you could multiply straight across, but you might catch this first. 3 and 9 are each divisible by 3. Oops, I was about to write 3. So they're each divisible by 3. So when we divide 3 and 3, we would get 1. Divide 9 by 3, we would get 3. So it really is just 10 times 1 is 10. 3 times 1 is 3. So it looks like it should be 10/3. Okay, so positive 10/9 times a positive 3 becomes positive 10/3. And then we need to get y completely by itself, so that's to subtract 8 on both sides. And we will have it after this. So we'll have 10/9, y equals 10/9 x. Now 10/3 minus 8, again, I'm just going to do some scratch work to the side. Remember with fractions, you need a common denominator. So that means that second fraction needs to get multiplied by 3 on both the top and bottom. So that way it would be 10/3 minus 8/16 24/3. And then now we subtract. Remember, with subtraction or addition, the common denominator stays as is, and then we will just subtract through the top, so that would become negative 14/3. Okay, so it would be minus 14/3 right here. So that's our equation. There we go. Okay, and to save time, let's keep going, but you could check it if you plugged in these 2 points. Verify that the 6 and the 2 plug in and it works. Same deal with the -3 and the -8, just like we did with that one with this setup right here. Okay, so you could always double check. All right, this next one has fractions in it. All right, so fractions just mean it's a little tougher with the arithmetic. If you have a calculator, though, or if you're allowed to use a calculator, I mean, we could use that. I'm going to go ahead and do this one by hand, though. Okay, so it is similar to the second one that we just did here, because it is 2 points. So we do need the slope. Okay, so let's get that slope. All right, so we've got, and let's label it x1, y1, x2, y2. So we've got m equals y2 minus y1 over x2 minus x1. Okay, so there's our same old slope equation. And what we've got this time, well, with fractions, again, we could still kind of plot it to make sure that our line is going to be correct. Okay, so 1/2 is somewhere over there, we'll say, and then -5/4 is somewhere down there. And then 1/4 is smaller than 1/2, so let's put it right there. And then -3/4 would not go down as far as -5/4. Okay, so they're close together, but it is a line that goes downward. Okay, so it should be negative, and so let's verify that with our equation. So we have -3/4 minus -5/4 over x2, which is 1/4, and then minus x1, which is 1/2. Okay, so let's continue working with this where I'm going to get rid of those parentheses because I can see I have a double negative. So let's write it as -3/4 plus 5/4. Down below, notice I have 4 in the denominator. Let's put a parenthesis like this. So with our big fractions, we have these implied parentheses around the whole numerator and around the whole denominator. And so 1/4 minus 1/2, I'm going to do 2 steps in one here. We would need a common denominator to simplify, so that would get multiplied by 2 on both the top and bottom. So we would have 1/4 and then minus 2/4. Okay, so I'm just kind of setting it up to get ready to do the subtraction. Now, in the numerator, we can simplify this. -3/4 plus 5/4. Remember, the denominator stays as is, the 4. And then -3 plus 5 would be a +2. So there's the simplified numerator. And then down below, we have 1/4 minus 2/4. Well, that would simplify and give us -1/4. Okay, and then my drawing's kind of in the way. Let me go ahead and erase that to make sure we have enough room, enough space. Okay, so we did say it was going downward, though, just as a resketch. Sorry about that. But remember, to simplify fractions at this point, we could do the division symbol instead. So 2/4 divided by -1/4. And then we can do keep, change, flip. So keep the first fraction, change the division into multiplication, flip the second fraction. And when you flip, remember the negative, the negative's just hanging out wherever you want to put it. We're flipping the 1 and the 4. And then from here, well, we could say, well, if you're multiplying, remember you can cancel with numerators and denominators. So the 4s would cancel. And then we really have 2 times -1 is -2. 1 times 1 is 1, so let's just say our slope is -2. Okay, so after all that, our slope is kind of a nice number. It's just -2, so not a fraction. Okay, but now that we have the slope, we have our point as well. And again, you can choose whichever one you want. Neither of them are if one's easier than the other, then go with it. These both seem not very nice because they're fractions, but I'm just going to use that first one. And then now we can set it up with our point slope form, and we'll plug everything in. So we have y minus our y1, which is -5/4, equals our slope, which is -2, and then x minus x1, which is 1/2. Okay, and then let's do 2 steps in one here. So we will distribute the -2. Let's start with that right side. So -2x. And then -2 times a -1/2 would be positive. And then 2 times 1/2, well, again, just some scratch work. The 2's would cancel, and we would be left with 1. So 2 times 1/2 is 1. So we have -2x plus 1 so far on the right. And then on the left side, well, we do have a double negative, so let's just write that as y plus 5 quarters. Okay, and then now I want to completely get y by itself, so all we have to do is one last thing, subtract the 5 quarters. And then we'll have it. Well, I will run out of room here, but let's do the scratch work. So I'm doing 1 minus 5 quarters. Okay, so getting a common denominator, we would have 4 over 4 minus 5 over 4. And then remember the denominator stays the same. 4 minus 5 is negative 1. So what we'll have, so the y would be by itself, and then equals, the negative 2x is still negative 2x. And then the 1 minus the 5 quarters was minus 1 quarter. And there we go. There's our equation. Okay, so we found our equation. And again, we could check it. We could plug those points in to see if it works. Or if you have a calculator, we could also plot these and show how to break it down. I'm going to kind of assume that we'll be doing these by hand, though. So probably won't use the calculator yet. Okay, so with our two other problems, we've got our special cases where we've got parallel, and then number 5 is perpendicular. But for number 4, sorry, they're talking about parallel. So remember, parallel means that they would have the same slope. So they're saying through this point, so they're giving us the point right away. Let's just go ahead and mark that. So our point is ready to go. Our slope is the same as this one. So our slope is 2/3. Okay, so they gave us the information, and then now, again, we'll just plug it all into our equation. Okay, so let's do that. Let's plug this in. So as long as we know what it means to be parallel, it's not too bad. So we'll plug these in. So we have y minus negative 8 equal to the slope of 2/3, and then x minus x1, which is 2. All right, and then now let's solve for y. So let's distribute the 2/3. And we'll do the minus and negative is plus. Let's go ahead and do two things in one again. So y plus 8. Distributing the 2/3 would give us 2/3 x. And then 2/3 minus, the minus stays, 2/3 times 2. I can put a little 1 there. 2 times 2 is 4. 3 times 1 is 3. So it would be 4/3. And then our last step would be to subtract 8 on both sides where the like terms are, and then that's going to give us, all right, y is by itself now. 2/3 x is ready. Negative 4/3 minus 8, again, just some scratch work, would be negative 4/3 minus 8/16, 24/3. And then negative 4 minus 24 is negative 28, and then over 3. So it's a minus 28/3. There we go. Okay, so that's how we can do it. So notice the pattern on these problems. So it's moving around weird. So notice the pattern on it. There it goes. Okay, so the ink got a little weird on it. Okay, so notice the pattern, though. Once we get onto the pattern, it's kind of similar steps each time. Okay, one other. This time it's the same point and same equation as the last one, but they're saying perpendicular. So again, our point is ready already. So x1 and y1. Perpendicular means to do opposite reciprocal. So this has a slope of 2/3. We want the opposite reciprocal of that. So for our problem, opposite, well, change it to the opposite sign, so it would be negative. And then reciprocal means to flip, so 3/2. Okay, so these are the ones that we want. So don't use 2/3 anymore. We're done with it. I'm just going to cross it out to avoid any confusion. We're using the negative 3/2 because we want perpendicular. Okay, and then now we'll set it up just like we did the last ones. So y minus y1 equals m times x minus x1. We'll sub in everything that we have. So y minus negative 8 equals negative 3/2 times x minus 2. And we'll continue simplifying. So distribute. Let's also go ahead and say the double negative on the left should become plus. So y plus 8 equals negative 3 halves times x is negative 3 halves x. Negative 3 halves and a negative 2 would make a positive. 3 halves times 2, and just some quick scratch work, the 2's would divide, so it's 3 over 1, or just 3. And then now one last step, subtract that 8 on over, and we'll have it. Okay, so we'll have y is negative 3 halves x. 3 minus 8 is minus 5. Again, be careful with that x. Just make sure it stays to the side or stays... You can write it up top like that. That's fine too. But be careful, especially like on things that you have to type in the answer. Don't accidentally leave the x down below. So if you did that, so if we're typing too fast or writing too fast, this is wrong. This would not be the same thing. So be careful. Okay, so that mostly would just kind of come into play when typing. Okay, anyway, so usually we just leave it to the side though. Okay, so just to the right of it. Okay, anyway, so I could have mentioned that earlier, certainly. Oh well. I think though that this is good. All right, so if you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.